WMI and CIM, executing instance methods. Now, so far, we've primarily been working with the properties of repository objects. We've looked at versions and architectures and sizes and stuff like that. But many repository classes expose methods, and PowerShell actually adds a few methods. These allow us to take actions, restarting a computer, triggering a service to stop or start, all kinds of things. So we're going to explore some of these, and we'll do so both with the older WMI commands and the newer CIM commands. This is also, in some instances, going to require us to get back into object enumeration. So hopefully you remember working with the for each object commandlet, because you're going to see that again too. We have some fairly diverse syntax to work with, and I'm going to try and make it really clear as to what goes with what version. But throughout all of this, I'm going to show you how to find methods and their documentation, as well as how to identify methods that are native to a repository object versus methods that have been dynamically added by PowerShell, and why you might care about that difference. I'll show you how to execute methods using the WMI commands, using the CIM commands, and in cases where those fail, how to manually enumerate those objects in order to execute their methods, kind of using a more programmery syntax. We're also going to get into some tricks with method arguments. There's a few methods in here that are a little bit picky and kind of have a lot of arguments and use some weird syntax to kind of approach it. So I want to make sure you kind of see all these things so that none of them create an issue for you when you start working with them in your job. Let's begin on my Windows 7 computer in PowerShell version 2. Now we're going to be talking about, as I said, a pretty broad variety of things that all relate to the concept of methods. The first one I want to talk about, though, actually relates more to the concept of properties, although there's a method that comes in a surprise ending at the end. So let's, what's a good one to play with here? Let's do logical disks. In fact, I'm just going to put this in a variable called disk to make it easier to get to multiple times. Get WMI object, class Win32 logical disk, and I just want to get the instance that has the device ID C:. Should be my local drive. Let's take a look at that. There it is. Now if you pipe this to get member, you'll notice something interesting. Look over here at these properties. You'll notice that a lot of these have a get and a set option. Now the deal is, if it says get, that means it's read only. If it says get set, you should be able to read and write to this thing. Clearly though, that is not true. You cannot change the size of the logical disk merely by changing a property. So don't get too excited when you see these gets and sets. All the properties are readable, so they should all have a get, or a getter, it's called. Even if they say they have a setter, sometimes it won't work. You kind of have to apply some common sense. And sometimes even if you're applying common sense, for example, what did we decide the volume name was? Local. Common sense would suggest to me that the volume name should be something I should be able to change. Common sense suggests that I can't change the drive type from a local disk to a CD-ROM simply by changing that property. However, even sometimes common sense says I should be able to change this. The underlying code just isn't implemented properly, and so it won't work. I'm telling you, there's some trial and error going on here, and you'll just have to try things. But let's take volume name as an example. Having put this into a variable called disk, I should be able to change the volume name. Now if I just look at disk, you'll notice that it's changed. But that doesn't actually save anything. You typically also need to call the put method of the object. Now that is always followed by parentheses. There are no arguments in between those parentheses, and you cannot have a space between the word put and the opening parenthesis. That should have changed it. Now if I look at disk, it's going to say that because that's a cached object. What I actually want to do is do a get WMI object and re-retrieve the class. And now you can see that it is actually permanently changed. So that's one use for methods, specifically the put method. The next thing we need to do, let's get WMI object Win32 operating system and pipe it to GM. we need to differentiate between the methods that are native to this repository class and ones that are dynamically added by PowerShell. Anything that says method is something that is a native part of this. So the operating system class natively knows how to reboot, how to set the date and the time, how to shut down, how to do a Win32 shutdown. We'll find out what the difference is in just a second, and how to do a Win32 shutdown tracker. You will also occasionally see a script method. These are not a native part of this object. They're added by PowerShell. So you will not see convert from date time or convert to date time included in this object's documentation. Let's work with this last bit first. It is often easier to pop the class into a variable. Now, if you look at the output of this, FL star, you'll notice that we've got these funky date time things going on. Where's last boot up time? There it is. Last boot up time is this. You can start to interpret this, but 2013, 09 looks like the month. That looks like the day. The time is in this serial number with a negative offsets. This is the time zone offset in minutes. It's how many minutes my computer is off of UTC. So what they give you is OS convert to date time being a specific type of object. Convert to date time is a method. So again, there's no space after the method name, and you must have the open and close parentheses. These particular methods require you to tell them what you want converted to a date time. And in this case, I want to convert the last boot, was it last boot time or last boot up time? Last boot up time. And that will actually convert that to a full-on date time object. Now because it's a date time object, I can then use methods of a date time object to put it into different formats, or use its properties to grab just pieces of it. If you pipe that to get member, you'll see that it is indeed just a system date time, and it's got all these properties and methods that you can play with. So that's one type of method that a WMI object has. Now PowerShell adds those two script methods to every class that it has been told to do so. That means it's entirely possible you're going to query some WMI class that does not have a convert to date time or a convert from date time. But that's kind of okay. All you need to do, let's see, where's my command? All you need to do is query any class that does have those, and then in parentheses, give it whatever you want to. This could be a completely different object. Right? So I'm using the convert to date time method of this instance, but the date time I'm converting might be something else entirely. You can always check get member to see if an instance actually has the convert to date time or convert from date time. So very useful trick. Keep in mind it's there for you to use. Definitely makes dates and times a lot easier to work with, and you'll run across some classes that have got an extra script method or two on top of those that are specific to the things that class does. Now let's play around with some of the native methods, the real methods. There's a lot of different ways you can go about this, so I'm going to kind of show you maybe 4 different ways, and we'll play with some different methods too, just to create some variety. So first up, I'm just going to retrieve the Win32 operating system class from my client computer. And that's my Windows 8 computer actually. So let's just look at that quickly and get member and confirm that it does have that Win32 shutdown. So now that I have that in a variable, I can simply say Win32 shutdown. Don't make the mistake and put the underscore in there. The method name doesn't have an underscore. There's no naming consistency here. The class name is Win32 underscore operating system, and it has a method that also happens to have the word Win32, but doesn't have an underscore. And we'll give it a 4. Now, real quick, let me switch you over to that computer so you can see that I am in fact logged on. Now that's a remote desktop connection, so my expectation is the window will go black and I'll get a disconnected. And I actually heard it just log off. So a return value of 0 means good news. If you get a return value of anything else, you'll have to look on the documentation page to see if anybody bothered to write down what that return value means. Most of the time they didn't. Let's take a look here. Yep, remote desktop session ended. Perfect. So that's that one. You know what? I'm going to relaunch that dude. Just so we can use him. Oh, there he goes. All right, so I'll just leave him logged in. We'll go back to the Windows 7 computer. Now, another thing you can do, let's get WMI object Win32 service from computer name win7.lab.pri. Oops, no, that's client. Client.lab.pri and dc.lab.pri. Win32 service, okay. I'm just looking. Wait, that was a little bit more than I needed. Let's select server and name. Trying to see if there's a service that these guys maybe have in common that if I play with it, I won't break the entire universe. BITS, the Background Intelligent Transfer Service. Not that it's not important, but you can live without it for a few minutes. BITS. Okay, so they both have BITS. Let's just get name equals BITS. All right, and let's also select off the state. Okay, so it's running on the client and it's stopped on the DC. Let's go to our interwebs and see if there's a method of this thing. I don't actually need to do this, do I? I can just pipe that to get member. I'm looking to see if there's a method that'll stop or start it. I don't know why I needed to go to Google. Start service. Perfect. So here's what we're going to do. I'm going to pipe these to invoke WMI method, and I'm going to invoke the start service property, or method. Now on the first one, I got a 10, but that's probably because it's already started. The second one I got a 0, which is successful, so let's re-query those. It's running on both of them now. So let's go back and do another invoke WMI method and run a stop service on them. 2 successful return values, and they're both stopped. So that's another way you can do that, is by using invoke WMI method. Now it does not actually require you to do a get and then an invoke. You could also, I think, so they're stopped now. So invoke WMI method, class Win32 service, computer name, client.lab.pri, dc.lab.pri. Actually, DC was stopped to begin with. Let's leave that one stopped. Start service. Oops, invalid method parameters. Invoke WMI method, class Win32 service, computer name, name, start service. I don't think I had to specify an argument there. Sometimes that's a little weird for me. But you know, that's actually a good segue. Let me show you one that is really useful, that is really hard to get working. Here it is. It's the change method. So this is the Win32 service class. It does have a change method. We can see it in the output here of getMember. It's right there, change. Takes a whole mess of parameters. Display name, path name. Essentially, you can change any portion of the service's configuration. The trick with this is if you don't want to change something, you pass null. Now in PowerShell, that would be $null. So let's say I only wanted to change the start mode. I would have to give it a null, a null, a null, a null. So 4 nulls, and then the new start mode. I could omit the remaining parameters entirely. Because they're at the end of the list and I don't want to change them, I can just leave them off. So I would only have to pass in 5 arguments. But let's make this interesting. I want to change the password. So let's say I've gone in, I've changed the Active Directory user account that the service uses to start itself. Now I want to go and tell the service to log on using that new password. So I need to do 1, 2, 3, 4, 5, 6, 7 nulls, and then the password. All right. We'll do this with my DC. It wasn't running bits to begin with, so hopefully it won't break things too much. Computer name, lab.pri, invoke WMI method, name, change, argument list, 1, 2, 3, 4, 5, 6, 7, the new password, and then I can omit the remaining 2 or 3 arguments because I don't need to play with them. Doesn't work. The problem with invoke WMI method, it has a few problems. There's methods I've seen it just not work on for no reason, at least none I can tell. But it also does not like nulls. It expects this argument list to be null terminated, which means when it sees a null, it assumes there are no other arguments coming. So that leads me very nicely to another way you can invoke methods. Let's say you've got multiple computers you need to run this thing on. Rather than doing invoke WMI method, we're going to use for each object. And in its process block, I will take $_ change, open parenthesis, close parenthesis, and close the script block. So I'm really doing the same thing that I did when I did the Win32 operating system the very first time. I have a variable. Now in this case, it's $_, which PowerShell is filling in for me, a dot, the method name, open parentheses, a comma-separated list of arguments, close parentheses. All of that is contained in squigglies. Now that means if I pass in multiple service objects from getWMIObject, for each object, it will execute the change method. And I should get a... Why am I not in the shell? There it goes. Whoa! Now the problem is... Oh, this is not good. Thank goodness they're virtual machines and I can fix them. The problem is I retrieved all of the Win32 services from my domain controller and I just changed the password on the first, I don't know, 20 or so before I hit Control-C because I forgot to put a filter in. What I meant to do, oh goodness, filter name equals bits. And see, now I just get 1 back. You see how important it is to be careful? Now you might have thought, oh, well, you could have tested that with -whatif. You can't. -whatif only works for commandlets. I'm not executing a commandlet, I'm executing a method. If I had used invoke WMI method, I could have used whatif because it has whatif, but it wasn't working at all. So I'll probably have to roll my domain controller back to a snapshot. So long as I leave everything running right now, it'll be fine. Next time I reboot it, probably everything will break. That's not irritating. Anyway, that's another way that you can do this. So we've really looked at a few different ways that you could execute methods for WMI. You can put it into a variable and then execute the method like we did. You can get and then pipe to invoke WMI method, except that invoke WMI method just does not work universally. You could also get and pipe to for each object. And then inside the for each object squigglies essentially do this exact same thing. You could also, for some, use invoke WMI method directly. Although again, there's methods that I just can't get to work. So 4 ways of doing WMI methods. Now, everything I've shown you up to this point works on PowerShell version 2 and later. Now, unfortunately, because I'm using these older WMI commands, there's not any further investment. So the little quirks and personality defects of these things are not going to be improved and they're not going to go away. Now, I moved to PowerShell version 3 so I can show you the CIM equivalent of all this. Now, again, everything we did before works. I could do OS equals get CIM instance class Win32 operating system. That might as well mess around with our domain controller, right? Computer name dc.lab.pri. And then I can do os dot, give it a method name, whatever I want to do. So the techniques I showed you before work the same. What's different is the invoke WMI method CIM version. So invoke CIM method. Let's do this. Let's get CIM instance, class name Win32 service. Let's filter it just down to the bits this time. Just this one service on the dc.lab.pri. Then invoke. Oh, I have a really bad habit of typing WMI and hitting tab. You don't want to do that. You want to invoke CIM method. The method name parameter is the method you want to invoke. And then the arguments, instead of being a simple comma-separated list, they're actually a hash table. So if you remember from the documentation page, the password parameter, or password argument, was called start password. See, now I only have to provide that one, and it's able to match it up. I don't have to provide them in any particular order, and I don't have to provide a bunch of nulls. That works, return value of 0. So really similar approach using the CIM stuff, but a little bit nicer, a little bit, I don't know if you consider the syntax easier, but not having to just put an arbitrary comma-separated list of $null, I find at least easier to read and type. So same concept, you just kind of get there through a different method. So now you know where to find methods and their documentation for these repository objects, and you should be able to identify the difference between a native method and one that was dynamically added by PowerShell. But you should know how to execute them all, either using WMI commands, CIM commands, or even if you just have to get a bunch of objects and then enumerate them and execute their methods using that more programmery syntax with the parentheses for the arguments. And I showed you some tricks for method arguments too, so hopefully those won't trip you up too much when you start playing around with these in production. I hope this has been informative for you, and I'd like to thank you for viewing.